All right, what's going on, guys? So in the last presentation, we went over a few things, one being our sort of our problem set, what exactly we're trying to show with the model and how we're going to do it. So in the previous presentation, we went over the fact that there's two features, x1 and x2, each representing an input to a logic gate. And our final label, which is our, so you can think of it sort of our final logic gate, which the model will develop an intuition for in order to solve, is the not XOR problem. So when both features are the same value, it returns true, otherwise false. Okay, so that's our features and labels. X is a set of our features we fed as NumPy float 32-bit floats as X and Y. So in each one of these, this is feature 1, feature 2, and the labels for the 4 training examples. And we also went over the fact that x.shape is a 2x4 matrix of features and training examples. So with any sort of model, we sort of know we'll have some sort of learning rate. We'll have some sort of architecture. By architecture, I sort of mean of our ANN. We'll have an architecture. So we'll set those as none to begin with. And we can almost actually get started with our class. So our class is found in utils.py, which I import here. I'll actually import it every single time because it's a pretty small script. We just want to make sure that it's loaded every single time. So import utils, hyperparameters, learning rate, architecture. So for the time being, we'll just leave that be. And maybe I'll just call this train model here. So we'll do that right underneath. So our model, when we instantiate our model, we'll call it model. So for that reason, right underneath our hyperparameters, we'll call it model equals model. So what this is in fact doing is it's creating an instance of our model, passing it some default arguments, and then calling it model. And at some point, we'll have to, train model, right? That's sort of the same thing, but we'll train model. Maybe I'll do it like that, okay? Okay, so what we want to do is we want to pass the default arguments. So learning rate, we'll actually do the learning within the notebook. We won't be doing within the class. So we're actually not going to be passing learning rate into our model, but what we will be doing is we'll be passing our architecture in the model. Okay, so our architecture for the time being, to solve this sort of problem, you pretty much don't need anything more than a 2-layer ANN. And we'll create this modular, more modular later on. But for the time being, here, I'll zoom in a bit. We'll have a 10 by 10 hidden neuron layer. Okay, so we'll have our 2 features being fed into 10 neurons, being fed into 10 neurons, being fed into 1 neuron representing 1 or 0. Okay, so for our model, class model, we'll define our init method. Okay, and our own, as of the time being, the only thing we'll worry about is self-taught architecture as architecture. Okay, so we'll make sure that that's passed in and that the class is looking for it. And we'll save that as self-taught architecture. Okay. Next step is when we do our training, what we want to do is develop a model or develop a function to perform the feed forward of our model. Okay, so when we create a class instance of model and call it model, what we want to do is within our model, we'll be doing some sort of training, right? So we'll set it up as a loop. So we'll call it for epoch in number epoch. Okay. Right now we'll pass, but let's just make everything, I like to do skeletons of everything before I actually fully work on it. So for number epoch and number epochs, and then we can call number epochs here. And for the time being, because we'll want to see exactly what's going on, we'll set the number of epochs to 1. And you'll see exactly why, because we'll see exactly what the feed forward propagation is doing, what our weights and biases look like, so that it all makes sense to us. And it doesn't make sense to us when we're running on 100 epochs, because we don't exactly know what's the gradients and what the biases and weights are doing. So with that, so epochs and number epochs, right? So it's actually range, right? Not number epochs, else it's just going to loop through 1, which doesn't make much sense. So at some point, we want to do the feed forward. So what are the steps to a model? Okay, we want to do the feed forward, right? We want to develop a loss. We want to determine gradients. We want to apply gradients. And we probably want to show some sort of accuracy, right? That would be nice. And usually with accuracy, if we're running for over, let's just say we're running 5,000 epochs, you sort of don't want to see accuracy for every single epoch, because then that just becomes cumbersome. So we'll do something where, again, we can do the skeleton here and it makes sense to us. So what we could sort of do is, so for a number of epochs, for example, are 100, okay? Let's just say we want to see the accuracy and the progress every 10 epochs, right? So what I can do is I can sort of say that if epoch, which is the current epoch, so 0 to 100, so if epoch modular, I want to say 10 equals 0, show accuracy. How about we'll look at the loss too, right? So one thing about this is, if we set it to 1,000 epochs, well, it's going to print quite a bit, right? So what we want to do is, rather than 10, we can sort of say, right? So if number epochs, so what this is in effect doing is, it's going to, no matter what our number of epochs is, it's going to give us 10 prints of accuracy and loss, right? And you might see that if we set number epochs to 101, this is going to evaluate to a float, and modular doesn't make sense. So we're just going to floor it, okay? So divide, we'll just round it. I think it's floor. I don't think it's ceiling. I have to double check that, okay? But for the time being, we'll stick to number epochs equals 1. Actually, that's going to return an error, so we'll leave that 10. Okay. So because we want to do our feed forward, at some point, what we want to do is, again, we want to do a feed forward. So what is a feed forward exactly? Well, we're feeding our features in and producing a prediction, right? So we'll call it y predict model, and we'll pass in our features here, okay? So this is what the model is doing. So because we're passing in x directly into the model instance, this will have to be a call method, right? So we'll call self, and because we're passing an x, we need to make sure that x is there, okay? Okay, so we have the architecture and we have the call. So the question is, within call, what do we want to do? Okay, we want to do the feed forward, right? Maybe I should make that comment here, right? So what this is it's actually performing the feed forward that we want. Right, so we want to return feed forward. Args are our features. And what's the size of x? Well, size of x is 2 by 4. And we want to return y. And what we want to do is we want to return, what exactly do we want to turn? Well, we have 4 training examples. So for every training example, we want to have a prediction. And we want one prediction, for each one. So it's going to be a 1 by 4 matrix that you want to return. Right? So we know exactly what we want, what we're feeding in, and what we want. Okay. So within our call statement, the first thing we want to do is the feed forward. Okay. So we know in a feed forward, in a model, we're performing some sort of matrix multiplication, right? So for the time being, everything's in skeletons now. Matrix multiply, weights, x, plus bias, right? That's what we're thinking about doing. Just make sure everything's okay. Everything's okay with time. We've got a few more minutes. So that's what we want to do. But the problem is that at this point, we have x, but we haven't initiated our y's and b's, right? And we actually can't initialize our I say y's, our w's and b's, because this is a call method. So this call method, we're going to be calling in fact, 10 times or 100 times or 1,000 times. So we don't want to build our weights and biases 1,000 or 5,000 times. So what we actually need to do is we actually need to build our weights and biases. So we'll do it something called the build method, okay? And you'll see exactly what this does. So what the build method will be responsible for is initializing weights and biases, okay? So at some point we need to init weights, init biases, right? Because in fact, every single time we develop a model, we want to do that only once, right? Yeah, so we only want to do that once. So because we only want to do it once, one thing we could do is put it in the init method, right? So we can do it here, right? We can, this is sort of a placeholder, but we can init biases and weights, right? But why don't we want to do that? Well, at this point, we don't really need to feed in the X's and Y's, right? So what we're going to do is we'll do something sort of creative where, yeah, so we'll do something creative where every single time we call, we'll do call, we'll check to see if it's the first epoch, okay? So one thing we could do is if epoch, right? Well, it's the first epoch, so it starts at 0. One thing we could do is we can set it to check if it's 0, if it's the first epoch. But the thing is, we actually really don't want to pass in the epoch every single time we do model. So what we could actually do is we could actually set at the beginning, where when we create our model instance, we can sort of say, well, if self.built is false, what this is saying is the model built at this point? No, right? But when this happens, we can sort of say, hey, is it built? So if self.built, okay, one day we'll write that right. Okay, so if not self.built. So what this is doing is check if run for first time, right? So it's going to do call for the very first time. Has it been built yet? So this will evaluate to, this would evaluate to true because it's not false. So this will evaluate to true for the very first time. And if this returns true, we'll build, right? So what this is doing is, has it been built for the first time? No. We'll self.build it. And when it builds for the first time, we're going to initiate our weights and biases so that for the second, third, fourth epoch, it's going to go back here. If not self.build, and it's going to evaluate to false, right? So we need to make sure that self.built evaluates true for the next time, right? So that every single time we run call, this will not get run the second time. So with that, I think that's a good length for our pretty much our first video on actually developing the feed forward. So we sort of have a skeleton for how exactly we want to initiate our weights and biases. We sort of know how do want to feed our architecture. And additionally, we sort of set up the skeleton for our feed forward, what arguments we're going to feed in, what we're going to return, and sort of on the outside, what it's going to look like, right? So we're going to have a feed forward loss. We're going to evaluate gradients. So we'll call that eval gradients. We're going to apply gradients, and then we're going to show some sort of accuracy or loss, right? So for the time being, we're just going to run that as pass just so that it will run successfully. And with that, we'll see you guys next time.